And hi, my name's Gary Taylor, and in this video we're going to have a look at Dapr. We're going to get started and hopefully have a bit of a play about and get this running on my local machine and just get a feel of what Dapr is and how to get started. So let's go over to the main website at Dapr and go to the docs, and we can see this getting started section. So we've got this nice little wizard that allows us to click next and keep going through this process, which I really like. And we can choose what type of operating system we want to start on. I mean, I'm running on a Windows machine, but I've tried this on Linux and it's just a breeze. So starting off with Powershell, not my first choice, but let's give that a copy and let's get Powershell open. So let's have a look at the remainder of these docs. Yep, we run Dapr, we got the console, so it proves that we're okay. So the next step, initializing Dapr. Right, okay, I thought we'd done everything we needed to get Dapr running, but apparently we need to also initialize Dapr as well. So why? What's going on here? Well, from the looks of the documentation, it appears that Dapr is an application that runs at the side of your existing application. So imagine if you had 4 applications, you would have 4 instances of this Dapr system running at the side of your application, and they call this a sidecar. It's common for Docker now to, if you want to expose some kind of services, you can have a sidecar that sits alongside your main app. And this is quite cool. I talked about this in the intro to Dapr. It allows us to implement features and access stuff that isn't in our native code. It's in the sidecar. Now, as part of the initialization in your local environment, we kind of get a few things as part of this. Redis, Zipkin, default components folder, and a Dapr container instance. Okie dokie. And the recommended approach is Docker. Well, yeah, that's my recommended approach as well. So let's have a look. What do we need to do? So Dapr init. Let's go over and put that in. So let's do Dapr init to install, initialize these systems that are needed. So this downloads and installs. Just wasn't sure if the screen recorder had stopped, so apologies for that. That's why I'm looking down at the bottom. So yeah, we successfully installed the components that are needed. Okay, so it says it's initialized everything and successfully installed the Dapr runtime binaries that are needed. And we say that we've actually got now a container that's running. So if we have a look at Docker, we can look at the processes with the ps command to see all the running processes, and we should see a number of things that are running. For instance, the Zipkin and Redis cache. So let's do Docker ps, and we can see that we have got a Dapr container, we have got Zipkin, and we have Redis. And don't worry about the container, that's just orchestration, so I can see my running instances in a pretty GUI. But we can see a couple of things now that have already been configured and set up for us, which is pretty cool. So let's talk about that a little bit more. So here we can see again at the bottom that we can verify that everything's been initialized. We have a Redis container, a Zipkin container. We also have a Dapr container, and we also have this folder that has been configured. So let's go and check that that is there. And awesome, yeah, we've got this folder and we've got components. We have a bin directory which seems to have a Dapr daemon and some other stuff that I'm not quite sure what it is, and I'm going to leave it alone so I don't break it. I'll have a play about with it at some other time. So being a little bit nosy, I just want to dive into these files and have a look what they are. You can see kind of got some configuration, very similar to like Docker Compose or to Kubernetes kind of configuration, in that we seem to have how we configure Dapr itself and the endpoints, Zipkin and sample trace. So we've got Dapr config, we allow tracing, we sample probably at 100%, and I think we've got Zipkin, yeah, so we get Zipkin for free, and I'll talk about that in a sec. We have state, so there's our cache. We've got a state system, which I think is going to be called State Store. It's going to be Redis, and we're just going to connect on localhost on that, which is probably going to be exposed via Docker. PubSub, what we're using for PubSub, Redis, yeah, because Redis is quite a good publisher subscriber thing. Okay, so I'm not too sure about these things yet. Let's dive across and have a look at the rest of the samples, and let's see how all this glues together. So the installer came and initialized a number of things. We have a Docker Redis cache. We have a Zipkin system, and Zipkin just allows you to see how communication between different services is happening, and you can trace it, you can log it, you can see that communication happening between your services. Vital that you have something like that when you're dealing with any kind of distributed system. And then we also have a Dapper container that I'm sure we can call and do stuff with. But then in the background we have, of course, the Dapper executable, and then we have a folder in our current, in our local folder that configures how our default components should work. So Dapper gives you access to components, and components are things like Redis cache, Zipkin, SQL Server, SendGrid, and lots of other useful cloud-based tools that I talked about in my intro. And you can configure how you want your default components to look like. So this seems to be like the initialized setup of Dapper. So this should be Dapper setup. Let's go to the next step. And we can use the Dapper API. Okay, we can use the Dapper system directly instead of it being in a sidecar and having to deploy an image and having to deploy one of your own custom containers with a Dapper sidecar at the side of it. What we can do is we can just simulate this by running and calling the Dapper application directly. So if we run the Dapper sidecar by doing Dapper run, we can provide a name for our application, because of course we want to make sure we've got a unique name, and then we can determine the port that it's going to be listening on. So let's give this a run. This is just going to run a very basic Dapper HTTP app. It's not going to be running in Docker, I don't think. It's just going to be exposed on that port, and it's just going to be running within this. This is the equivalent of running .NET Run, or Go Build or something like that. It's just going to run this app. So let's give it a run, and hopefully it'll start up on that port, and I've got nothing else running. Awesome, it's running. And this is simulating. No, it's not simulating, it is a Dapper sidecar. So instead of it having to run in Docker and set that up for the moment, we can just run it quickly, which is pretty cool. And we can see how it's registering stuff. I'm not going to get into detail of this, otherwise this will turn into a 2-hour video. But for now, this is just the Dapper sidecar running. And if you can cast your mind back 20 seconds or so, we had some default components that were running, and one of them was state and PubSub, both using Redis, I believed. So what we can do now is we can try and access a cache. Now I think this is where the power and eureka moments come around this stage, is that we want to be able to save something to state, to some cache somewhere. So what we're going to do is we're going to save Bruce Wayne as a name key. I would have named this differently because it's a bit confusing. We've got the name Bruce Wayne. I'll explain that in a second. So let's copy this, and what we can do here is we can post a request using a cl post command, and you can just copy that and paste it into the command line. Then you can get the value back by asking for the name, and the name is actually the key. And that should then come back with the value Bruce Wayne. We could also double check this if we care, which we shouldn't care. The whole point of Dapr is just run it, I don't care how. But if you wanted to, you can then actually dive into the Redis cache and go into the server and check to see that the value's there. Well, I think that's going a bit too far. I personally wouldn't have had this in the docs. I don't think it's needed at this early stage of getting started. I think it actually confuses people because it makes you not see what's the magic of what's going on here. And then we can delete that. So let's go and give this a play. Let's see if we can run this. Now I'm over in Rider, and also Visual Studio Code or VS Code has the plugin to just allow you to paste your command in and click a run button, which I find incredibly useful. However, you can just copy and paste the URL into the command line and CL will run, but I just find this a little bit easier. So what we're going to do is hit this endpoint here, which is the running app that we just started. We just started up a sidecar, and now what we're going to do is access that sidecar using just a CL post command. And we're going to connect to this thing called state, and that's the component. So state is the component that we want to connect to, and we're just saying give us some state. So notice it doesn't say Redis or anything like that, because we do not care how it's done, whether it's memcached or Redis cache or SQL Server. We don't care how cache is being stored. It's just none of our business. It's just a tool. Like, for instance, we don't care about how the intermediate language is built down, really. We just write our C# code. Abstract it away. Make it so it's not a problem anymore. So we can call a post, and this will then send out the details to our container, our app that's running in the background. Now, I was hoping to see some kind of messages occur here, but it didn't seem to. So we'll have to have a look at that later on. But we can see that a request was sent and there is no content back, but we did get a success message. If we now run the get and we say, right, go and get state store, and state store is the name, the unique value that we want to use of our state system. So of course we could have, if you have a system called Alex, you could call that Alex. If you got another system called Bob, you could call that state Bob, and then you can put data in. Then you can do state Bob, get a key, get a value, get a secret, get a password. Well, not a secret, you wouldn't store that in Redis, but in state. So here we go. We're going to get this data. Let's get it back. So if I see now state get, and we see now we've got the value back as Bruce Wayne, and that value has come back from this cache. So remember, this value here, it's not that we've got this in state and because I'm running this here it's working. It's just saved it somewhere, I don't care how, and now I'm retrieving it from somewhere, I don't care how. So let's head over to Bash and let's run that command. And we can see Bruce Wayne came back. So it's got nothing to do with the fact that I was running it in Rider and it had memorized it in Rider. This is literally a state store now. We can store values and we can retrieve that value back from some state somewhere. So now in your application, if you need any kind of caching, if you have a system that is underperforming and you think that caching will improve it, as most cache will, then you can implement caching incredibly quickly. And now finally, let's say we don't want that item anymore, we can run a delete command on it. And the delete command will, of course, delete that state. So if we now get the value, we'll come back with nothing because, of course, the value has been deleted and it's not in state anymore. So I'm just going to reiterate the point again, just to put this deep inside your memory and your thoughts, is When we initialized Dapr, we implemented some kind of cache by default. The cache that we're choosing is Redis, but we could of course change that to anything we want as long as it's supported by the Dapr component system, or you could write your own. That's implemented into Docker, and we also have the ability to run a sidecar either in as a Dapr container or just run it as an application using the Dapr command line. But we also have this Zipkin thing that comes along for the ride. So before I go into Zipkin, I just want to show you this relationship between the app and Redis. By default, we have some state, and we have the ability to record state and cache. And we've called it state store. I don't like the name. I think we could have been a bit more original, because that makes it feel like this is all one blob. It's not. State store is actually the name of the configuration here. And if we look at state store, we can see that state store is actually a type of Redis. And these are the configurations, the usernames and passwords, and you can configure Redis to your heart's content within the rest of the metadata. So because I've decided within my HTTP post request to actually use state store, it's going to look at state, it's going to find all of the configuration, and there's only one, so it was pretty simple. But if I had 50 different state stores, see, I've said it myself, if I've got 50 different states, locations, all in different kind of systems, then I could configure them within this component. Dapr would look up this value, look up the component, and look up the actual location of where that state should be. So an easy one is I could copy and paste this and just change the names 50 times and have 50 different Redis servers running, and based on what configuration I ask for determines what Redis server it connects to get the data. So, if you have cross concerns, if you have Redis cache and you have a couple of them for security reasons, so that you've only got data that's shareable within one system, then you can configure all your different Redis areas within the components folder. So I really, really like this idea. And it's same with PubSub. We have PubSub, and I could call the endpoint to subscribe and to produce a message, and in the background it's actually going to use Redis. Well, I could use Microsoft Event Hub, I could use Kafka or RabbitMQ. And if I decide I want to move away from Redis as my PubSub handler, messenger, engine, whatever you call it, then we can do just by changing this config. The rest of my code remains the same. So the other bit that seems to come along for a ride is Zipkin. So let's have a look at that. So Zipkin comes on 9411 Charlie accent port, and you can just refresh and hopefully see all of the running queries. So excellent, we can see the queries that I've been running against this system, and we can see information about who did it and what did it. So there is an application running somewhere called My App. Well, yep, we knew that. And that was the name of the application that we fired up. Remember when we run the Dapr command, we specified an ID of an app to run, and we just called it My App. So like I said before, if you have an app called Alex, you would have called it Alex, and you would now be able to see the communication from Alex. So let's have a look at a bit more information. So we can drill down and see the type of request that it was, the protocol that it was using. We can see that this was a GET just to get the name. And this was the delete. That was a GET. I'm not sure if I'm going into the same one again. I think I am. quite sure what that one was. So I can't really find the put, but or the post. There'll be a way of configuring it and searching for it here. Now, at the moment, there's not a great deal going on because this app is really just connecting. We're just connecting to it directly, and it's going to cache directly. So there's not a great deal of interdependency going on. However, when you have many services communicating with each other, then this is where Zipkin comes to life, because you can see all of them communication channels. So heading off to Google, we can see that we can determine all the communication. We can actually see how traces work and how services call each other's other services. We can connect through to them. So this is really powerful. Now, you don't need to use this in production. You know, you might be using something like Datadog or some other tracing system, but it is really cool just to be able to get tracing up and running by default whilst you're testing and playing about, and then being able to see what's actually happening under the hood with your services. It's just incredibly powerful. So let's go back to the remainder. The remainder of this is really just showing you how to connect to Redis CLI. Well, I don't think this is useful. I don't care. Yeah, of course we can go to Redis and run the commands to get the data direct, but that's not useful for me. And we're kind of done with a quick start. It now starts going into other services, and you can see state management there. It is there. So before we wrap up, I just want to have a final play with this and just see if I can break it. So one of the things I'm really not happy with is the fact that they've used name, and we're storing this as name, and then we get the value back from the key, which is name, and we get back Bruce Wayne. I think for me that was a little bit confusing, because I'm more of a ID type of person. So let's see if I can change this. Let's make sure I've deleted everything. Okay, and let's change this now. So instead of Bruce Wayne, we have name. Let's call it first name equals Bruce, and then surname equals Wayne. Okay, let's add another one, which is age. Let's call him 31, because he never seems to age. And let's run that. So that seems to go in, and let's get that data back. And we now see we've got a nice JSON object with first name, surname, and age, but we're still using name as that key. So let's resolve that. Let's delete what I have. Let's create a GUID instead. We live in a NoSQL world, don't we? So let's copy that GUID. Let's put that in there, and then let's run. So that's the value going in. If I now get name, it's empty because there is no key with the value name. So I just wanted to make that really clear. I find that confusing. That is the name of the key, not the name of the person. So if I put that in, hopefully, if it runs, come on, I get Bruce Wayne. So that could be the unique identifier for Bruce Wayne. That is his ID reference number. And going to the cache with that value returns this data. So, you know, if we've got state, if we've got some information, we can store these keys, and then we can go to Redis cache and grab that data using that key. And then, of course, if we want to delete that, just deleting name doesn't work, because that's not the key value within Redis. I'm not going to say Redis, sorry. That's not the key within this state. We actually have to use the key we used for Bruce Wayne. So you can see Bruce Wayne still exists. Now, if I delete that key from our state, Don't know why that drop down keeps appearing. And then I go back and get the value for that key. It's gone, it's empty. So this for me feels like a more concrete implementation. I can see I don't get confused by things. I can see that my value that is being returned doesn't have to be a singleton, a scalar. It can be a complex object. I can post data in and I can get data back, and I can delete that data when I'm done with it. Now, as I decide to play about with this and maybe go into production, our DevOps team might have a different take on what they want as the state management system. So out of the box, the components supported with Dapr are all of these. So there is a great choice of what we want to use as our state store, including memcached. So if we have a look down now, we have a look at Redis, you can see all the configuration of all the things that you can set. And there's more being added on a weekly or 2-week cadence as Dapr do their updates. So we can see the ability to configure different settings within the cache, including things like the time to live, which is really useful for a caching engine. We can see how some of this config is optional. Well, if we look at the time to live, we can see time to live is 600 seconds, so 10 minutes. And we can configure that and change that if we want. So I'm just going to see if I can give that a go. Should never do this in a live demo, but let's try that out. Now, as we don't have an app that we're deploying along with our application, really the only thing we can do is manipulate our state store within our global components section, and that will really change every app that's running. So let's change that to say 10 seconds. Let's indent properly. Otherwise we'll have a bad day. Thank you, YAML. Let's save that. Now, because we've made a change to our components, which are our global components, we're going to need to stop that app. Now, I'm hoping that that is all that's needed, is that I can now run this again and it will reseed itself with them settings. So if I now go over and try and check my state and see what I've got. So let's get the state and it should return empty. Okay, let's post it in. Then let's get it. And let's wait a little bit. And let's see if I can get this data. And it's gone. Now, via the power of the magic of pausing the video and editing it, you didn't have to wait 10 seconds. But now this information only stays in our state system for 10 seconds. And then it's removed. So we can see that the value's there. And now it's gone. So even though I kept requesting the information, that didn't reset the 10 seconds. This state only existed for 10 seconds and then was removed. So remember that that's the way that this system works, which is quite common for a caching system. You have to refresh it yourself and reseed. So in order to make sure I don't have a bad day some other time, I'm just going to take that value out. Otherwise, while I'm developing, I'm going to be pulling my hair out, wondering where my state has gone. And that is an intro to Dapr. So in the next video, I'm going to start looking at the different components within Dapr and why they're useful. We've installed, we've got Dapr configured, we've got it up and running on our system, and we've also played about a little bit with state and hopefully got an idea of what Dapr's all about and how to use it. And I'm hoping that you'll agree that by not having to worry about how I manage state, It also means I don't need to care about the configuration of it on my local machine or the configuration of it on our servers when it gets pushed up to cloud or whatever infrastructure you're on. And this runs on anything. It doesn't matter whether you're on Azure, Google, or on-prem running some Pivotal system or whatever. This will run as part of any ecosystem, and it's quite easy to now replace your existing implementation. So if you have built in a Redis library and you've put it into your system, you configured it on startup, you have usernames and passwords configured in some key vault somewhere, and you're having to pull that in, and you've got all this boilerplate code configured, so now you can get a value in and out of Redis cache. Now you can just change that code, replace all of that stuff, all of the secrets, all the information, get rid of it all, and just add a HTTP call. And if you configure your tracing, you will always get tracing. So if you configure, say for instance you're using Datadog, you can configure that, and instantly now no developers made a mistake of, I forgot to set the environmental variables, or I forgot to configure such and such a thing. The latest template that you're using needed to be updated to support the latest version of something, and it's a nightmare. Once you start having more than 10 services, it becomes a problem. So for 1,500 services like some companies have, it's just insane amounts of work to keep up to date. This means that developers are able to build and deploy and scale their systems quickly without risk. So that was an introduction to Dapr. If you like it, please give it a thumbs up.